Good evening, everyone. Welcome to the October Tech Workshop, Appium 101, an introduction to mobile automation testing. My name is Peggy, and I'll be the host of this tech workshop. Before we get started, let me introduce our speaker today. We are delighted to have Karl, our iOS engineer, as our speaker. Karl has built an Appium automation testing project for a North American client and worked on several projects such as the DVS Car Plus iOS app. For the next 1 hour, Karl will go through the basic concepts of mobile automation testing and further explore the market trends and the features of Appium with hands-on practices and a demo. At the end of this webinar, we will have a Q&A session, so please feel free to send your questions anytime by using the chat box on your right-hand corner of the screen. We will collect all the questions and answer them after the presentation. Now, let's welcome our speaker, Karl.
Thank you for the introduction, Peggy. Hello and welcome everyone to our webinar today, Appium 101, an introduction to mobile automation testing. My name is Karl. I'm working here in Taiwan as an iOS engineer at TPIsoftware, but of course I also do have some automation testing experience. And one of the things I work on here at TPIsoftware is our own automation testing solution, but more on that later on. Our outline for today looks as follows. We will first look at what is testing in general. Then we will talk about manual testing before we dive into our main topic of today, automation testing with Appium. Here we will talk about how Appium works under the hood. We will see how we can write an Appium code or Appium script, how we would set up a test framework for testing an actual project, and we'll have a quick look at how a mock server or a CI/CD pipeline can help us with our automation testing. We will then summarize benefits and limitations of Appium. After that, we will have a demo looking at a few scenarios of what we can automate with Appium before looking at market trends, and last but not least, our own TPI's automation testing solution. So let's get started. So first of all, what is testing? So the English word comes from the Latin word testum, which represents an earthen vessel such as the one you can see on the right. These were designed to hold hot metal, and one of the use cases for this was to assay the metal for impurities, basically testing the metal. So by this, the process, putting something to the test, became associated with the word testum, or later on test in English. If you look at a modern definition, like one from Webster, test is a critical examination, observation, or evaluation, which leads to its acceptance or rejection. Now, we are more interested in software testing, obviously. So as a software tester, we need to get some kind of indication of the quality of the software that we're testing. And there's a huge number of methods and tools available that we can use for that. For example, if you look on the word cloud on the right, I collected all kinds of different testing methods for software that I could find online. Maybe there are some words in there that you have heard before. Maybe you've heard of unit testing, where you would test basically every functional, every bit of code in your software. But yeah, let's see how we could classify software testing. So there's a classification matrix that we could use, which would have the 3 items: test target, test type, and test method. So regarding the test target, this one basically tells us what we're trying to test. If we talk about mobile automation testing, of course, we want to test an app, but maybe the app has different layers. So we could say the test target could be the API or a code function, or also the user interface of the app. So the test target is talking about what aspect of the app itself we're trying to test. Now regarding the test type, well, it talks about what aspect of the app's quality we are trying to test. So an app can have a lot of different qualities. Maybe it is very performant, but the functional outcome is not that good. So if you think of an example of a calculator app, for example, it could perform the calculations really quickly, but maybe sometimes they're incorrect. In that case, you would say the app is as a good performance quality, but not a good functional quality. So an app has a lot of different qualities that we can test, like performance, functionality, or accessibility. Now, the test method basically describes how we're going to perform the test. Obviously, we could execute the test manually. For the UI test, for example, we could just use the app the same way a user is using an app, or we could also write some code to test our app. In that case, we would say we automated the test. So that would be an automated method. Now, our focus for today is UI testing. UI testing, the target of UI testing is testing the user interface of an application. As we mentioned before, that would be the test target. Now, we haven't mentioned anything about the test type and test method for that. So when we talk about UI testing, it is usually of functional nature, meaning we want to try to test the functionality of our app, that it is correct, and we're not paying too much attention to testing the performance or testing the accessibility of our application. Now, regarding the test method of UI testing, this can either be manual or automated, and we will look at both of them today. Maybe you wonder what a simple example for UI testing is. The most basic example you could think of is probably a login page where you would enter your username, the valid password for that username, and click on login, and then assert that you are logged in and the main page of the app is shown. That would be a very basic example for a UI test. Okay, so let's look at manual testing first so that we can compare it to automated testing later on. Now, in general, the first step when we talk about manual testing would be that we need to specify the test cases. So once we know the scope of our tests, we can then group it by features, maybe a login flow feature, a settings feature, a dashboard feature, etc. And in each of those groups, we will collect all test cases related to those features. To collect our test cases, we can either use a spreadsheet or also test case management software. Now, how does it look like if we are how does a test case look like? Well, there's one example in the bottom of the slide, with the most important parts being, in my eyes, prerequisites, steps, and expected result. So when you want to execute a test manually, of course, you would need to know the steps that you need to execute to follow the test case. But this is not the only thing you need to know. You also need to know where you have to start once you execute your test case. Maybe you need to log in as a certain user, or you need to be on a certain screen of the application. And then you can perform the steps as defined in your test case. After you executed all of these steps, you're then about to assert that the outcome is expected. So you would see what the screen of your app is showing and verify whether it's the same as your expected result. If it's the same, great. That means that your test was successful. If it's not the same, then your test has failed. Of course, there's also a lot of other information that we track in a test case. For example, you would have test ID and name to be able to talk about the test cases with your developers. You may have a description for the tester to know what the test is talking about, what the test is all about. And you can also imagine having a lot more fields if needed. Maybe you have a Jira ID that links to a development issue on Jira, or you have additional status fields for each device or OS version that you have executed this test on. Now, the tester can just follow the steps here to execute the test and then assert the outcome. This will need to be done several times during the development process. For example, the first time after the development of the feature is finished, the next time during the SIT phase, and maybe later on during a regression phase when a new feature is introduced, to make sure that there has been no regression on the previously tested feature. Also, the test may need to be performed on several devices and OS versions. So you could imagine, for example, that your app needs to support the latest 3 iOS versions, for example, iOS 13, 14, and 15. and maybe it needs to support all kinds of different phones. So you would want to test that it works fine on a small iPhone, like an iPhone 12 mini, that it works fine on a big iPhone, like an iPhone Pro Max, or that it works fine on an old device with a very slow processor, such as an iPhone 6s. So what we can see here is that the process becomes very repetitive and therefore prone to human error. I think most of us, at least me, we tend to make mistakes when we're bored. So yeah, this introduces human error. And also, it's a rather time-consuming and therefore expensive process, because we need to invest a lot of time testing this test case over and over again on different devices, different OS versions, etc. Now, let's talk about automation testing. We already had a look at the manual testing approach, and we know now that UI testing is very important. However, it's repetitive and time-consuming. So it would be great if we could automate that process as much as possible. Luckily, there are different tools available for that. As you may have guessed from the title of this workshop, Appium obviously is one of them. But there are also some other tools. Maybe you have heard of Detox before, or Android Espresso, or Apple's XC Test. But for the workshop today, we will solely focus on Appium. Now, what exactly is Appium? Appium is an open source automation tool. This means it's a tool that allows us to automate the user interface of an app that we want to test, but also of the operating system or other apps. Yeah, so it has several benefits, and we want to have a look at its advantages first, before we then talk about how it works and how to write code with it in more detail. So the first major benefit of Appium is that it supports several, for example, iOS, Android on the mobile side, but also Mac apps and Windows apps and some more. But yeah, for today, we will just focus on iOS and Android. We can automate our apps on iOS and Android, and we can automate them either on a real device, but also on a simulator or emulator. Another benefit of Appium is that it doesn't need a specific build. So we can just, if we want to, we can just use the regular version without needing to alter the code to test it. Also, as I already mentioned before, Appium can interact with your app, but also it can interact with other apps. So maybe you have a test flow where you're testing your app, but also the connection to maybe a Maps application or an email application. So Appium can do that. And it can also interact with the operating system. So you could open the notification center or the control center, for example, or the system settings. So this makes it very powerful. Now, Appium also supports several programming languages. That means we can write our test code in any programming language that we feel familiar with. For example, it supports Java, Python, JavaScript, Ruby, and some others. So this is great for us as a developer of the test case, of the test code, that we can pick the language we feel the most familiar with and also choose the testing framework that makes the most sense for us. Furthermore, Appium has a large community and has been around for a while, so there are a lot of resources available online. And yeah, you're pretty likely to find some help if you run into an issue. It's also based on Selenium, so if you used Selenium before, then the code will look very familiar to you. Now let's have a look on how Appium works under the hood. In general, Appium is not only one thing. It consists of several components, which are mainly the Appium client, an Appium server, and a driver. Now, Appium, as we mentioned before, supports automation of several platforms. So there's one driver for each platform, or to be more precise, there's one driver for each automation technology. For example, the Android platform has two automation technologies, like Android Espresso and UI Automator 2. So the task of this driver is basically the translation of the Appium API into automation commands for the automation technology that is used under the hood. One big benefit of this is that your code can partly be reused to automate different platforms and different drivers, but only to a certain extent, of course. There's no perfect feature parity, and you would also need to assume that you're testing the exact same app on Android and on iOS, implemented the exact same way. Now let's have a look at how Appium works with a diagram. Maybe that is a bit easier to understand. So this is an informal diagram showing us how Appium would work when automating an application on an iOS device. We can see it's broken down into 3 parts. This is to symbolize that they can, in theory, all run on different devices. So for example, your test script could run on your own laptop, the Appium server could run on an external server, and the WebDriver agent, together with the app that you're testing, could run on a iOS device connected to that server. However, that doesn't need to be the case. They can also all run on your machine, and that's probably mostly the case whenever you're developing and testing your test cases. So we can see here, when we write a test script, it uses library calls to communicate with the Appium client. The Appium client then uses the JSON wire protocol to communicate with the Appium server. With the Appium server either running on your laptop or on a separate machine. The Appium server then communicates with the driver, in the case of iOS, the XDUI test driver, and that again communicates with the WebDriver agent, which is an app installed on your phone that helps us to automate the app that we want to test or the operating system. So the WebDriver agent would then use, in the case of iOS, it was use XDUI test to use the automation commands of that library to automate our app or the operating system. So yeah, when we're running an Appium test case, we will always need to make sure that we have an Appium server running, either on our machine or on a separate server, and that we either have a simulator installed on that machine or that a device is connected to that machine. Now, this is a larger diagram that I found on Appium Pro. I think it's pretty interesting because it shows us all the different drivers that there are and how the communication would flow between them. We can see our iOS example again here with the XDUI test driver, and we could also see how the communication works for Android with the UI Automated 2 driver or the Espresso driver. Sadly, we don't have a lot of time today, so we're going to skip over that diagram, but you can get the slides later on, and if you're interested, you can take a closer look. Now let's talk about Appium script or Appium code. So if we want to write our test code, before we get started, we will first, of course, need to make sure that we install all the necessary software. That would at least be the Appium server, which you can either download as a desktop application with a graphical user interface or as a command line tool. And also, I would strongly suggest you to install the Appium Inspector, which is an app that helps you a lot in writing your test code by letting you inspect apps and find elements that you need to interact with. Of course, you would also need to install additional software like Xcode, for example, if you want to test on iOS, Xcode developer tools, as well as an iOS simulator or Android Studio and an Android virtual device, etc. But I assume if you're familiar with app development and you want to test it, you already have these tools installed on your machine. Now, the next step would be to decide on a language for our test script. As we heard before, Appium supports several different languages, programming languages that we can use to write our test code. In our examples today, we're going to use Java because it seems to be the most popular one and most resources are available for that. That also means we can use our preferred IDE to write our code and our preferred test framework. And in our case, we will also need to decide which app we want to automate or test. If you already have an app in mind, of course, there will not be a question for you. But for our examples today, we're going to go with Wikipedia because it's an open source application and it's relatively well known. Now, in general, interactions with Appium can be categorized in 3 to 4 different categories. So the first step that we would need to do would be set up the Appium driver. Additionally, there's finding elements and interacting with elements. And there's also the other category, which includes things like taking a screenshot, setting the orientation of the device, or setting the locale, stuff like that. So the first thing we need to do is setting up the driver. I have an iOS example here. So here we can see if we write our code in Java, a very basic example. Maybe we have a class with a main method. And here we will set up our driver. All we need to do for that is to create a desired capabilities object and then provide it with all the information needed for our driver. As this is an example for iOS, we would, for example, set the capability type for the platform name to iOS. We set the platform version, which is like the version number that we want to automate. We set a device name, which would be the name of the simulator we want to run the test on. And we would provide the capability for the application, which means we would provide the path to where our app file is located. As we're running on an iOS simulator here, we provide an app file. If you were to run on a real iOS device, you would provide an IPA file. Or if you were to run on Android, of course, you would provide an APK file. We also setting the capability for the WebDriver agent on which port it's running on. So this is the most basic way to set up your desired capabilities for running a test on an iOS simulator. Additionally, we will also need to set the server URL where our Appium driver can find the Appium server. As you can see here, we have set it to localhost. That means the server is running on our own machine. And we then inject the server and the capabilities into our driver and start it up. We also have an example for Android here. As we can see, it is very similar to setting up the driver on iOS. Just some of the variables are different. Of course, we set the platform name to Android. We set the platform version that we want to use. One of the capabilities that is different is that we need to set an AVD, an Android virtual device, that we are setting here to the virtual device that we want to run the test on. We provide the file of the application, an APK file, and we can also set our automation name here. As mentioned before, there are two active automation technologies on Android Espresso and Android UI Automated 2. So if we want to choose a specific one, we can also set that here. And then again, same procedure. We're setting the server URL and use that to set up our Appium driver. Of course, there's a lot of more capabilities in theory that we can set, but those are the most basic ones. For example, on the iOS simulator, we would be able to inject system settings, like whether locations should be turned on or off, or whether notifications should be turned on or off. Stuff like that can be very helpful for our test case. We could also inject the capability telling Appium whether it should reuse the app if it's already installed, or whether it should just reinstall it fresh from scratch. But yeah, this is just a basic example. Now the next step would be to translate our test case into test code. And now we haven't actually decided on a test case yet, so I came up with this basic demo test case. As we're testing Wikipedia, when you're opening up the application for the first time after you freshly installed it, it will show an introduction screen. So I thought for our demo test case, we can just click through the demo, through the introduction. And once the introduction is finished, we make sure that we are on the main page of the application. So what we can see again here, we have the prerequisites, the steps, and the expected result. And those are the three parts that we need to translate our test case into test code. The prerequisites here say the app has been newly installed and is open, showing the first page of the introduction. Luckily, Appium is taking care of that for us. So when we set up the driver with the Wikipedia app, it will automatically install it and then start it up. So there's nothing we need to do here, but we need to look at the steps and the expected result. For the steps, we need to click on the next button 3 times and then on a get started button, as it looks like here. This means we will need to find these buttons on the screen and then interact with them. As I said before, there's locating elements and interacting with these elements are two very integral parts of Appium. After we did that, we will then have to assert that our test case was successful, which means we need to make sure we are on the main page of the app. In our case, we know that there's a Wikipedia logo on the main page of the app. So we will try to find that logo, and if it's visible, we know we successfully get to the main page and our test case was successful. Now to interact with these elements and find with these elements, we need to have a look at Appium Inspector. As I mentioned before, I would highly recommend you to install Appium Inspector if you're writing Appium code. It's a very useful tool to inspect the application that you're trying to test. You can see a screenshot of Appium Inspector here. You have the screenshot of the app you want to test or inspect on the left. You have your page XML source in the middle, and you have information on the item that you clicked on the right-hand side. So what we can do here is we can select any element on the left-hand side in the screenshot that we want to interact with, and then get more information on it. For us, for example, the next button, of course, is very interesting because we need to click on it. So we could click on it here in the Appium Inspector and then see which locator strategies are available. Now we need to have a quick excursion on what locator strategies are before we can start interacting with the items. A locator strategy is a way for us to find elements on the screen using Appium. There are several different locator strategies available. The most popular one is the accessibility ID. This is usually the preferred choice for Appium developers. The original intention of an accessibility ID is to make it easier for handicapped people to use your application. But for us, of course, it has the big benefit that we can use this ID to find elements on the screen. The downside of this locator strategy, though, is that it has to be added manually by your developer. So it's not there by default. Luckily, it's very easy to edit, though, and if you edit, it will be a big benefit for you and all of your handicapped testers. They will be very happy. Another locator strategy would be the ID, which is basically the same as the accessibility ID, just without the accessibility benefit. Another very popular locator strategy is XPath. If you have used, for example, Selenium before, you probably heard of XPath before and maybe used it. Now, the big benefit of XPath is that it's available by default, so your developer does not need to add any code for you. However, it can be a bit brittle. That means if you change the UI on your screen a little bit, if you introduce maybe new buttons or new elements, an old XPath locator that you used before may not be usable anymore. So you always got to use that one with caution. It's not as reliable as an ID or accessibility ID. Also, it's not as performant. The more complex your screen is, the more time it takes for Appium to find an element on the screen using XPath. Especially on iOS, this can take a long time, as the screen on iOS is not defined as an XML, and Appium will need to translate the screen into XML first, before it then can start using your XPath to find the element. Now, there are also native locator strategies. Those are basically locator strategies that only work on a certain platform, like, for example, an iOS class chain or an iOS predicate string or an Android UI automator locator. They are, as the name suggests, platform dependent, so you can only use them on iOS or you can only use them on Android. The big benefit for them is usually that they're very performant, so they're very quick at finding an element. However, you cannot reuse them when you try to reuse your code on a different platform. And you can, when you use them, they are sometimes a bit hard to use, as you kind of write code within a string. So yeah, that can lead to issues as well. So the suggested locator strategy to go with would always be the accessibility ID if available. There are other locator strategies as well, but we will not look to them today. Now, for our test case that we defined before, going through the intro page of Wikipedia, basically clicking on next 3 times and then clicking on get started, we can see the code here. As you can see, we have our driver and we tell it to find an element. And to find that element, we're using the accessibility ID, the locator strategy of our next button. So our next button has the accessibility ID next. So it's very easy to find using this locator strategy. Once the element is found, we can then just use the click method to click on it. So in total, we are doing this 3 times, and then we should be on a screen with a Get Started button. Sadly, this Get Started button does not have an accessibility ID. So in this example here, we're using the XPath locator strategy to click on it. You can see the XPath looks like this, but basically the code is the same. Driver, find element, and once the element is found, we click on it. Now what you can also see here is that there are thread.sleep statements between each of those clicks. This is the case because when we're switching the screen, when we are navigating from one screen to the next screen, it may take a few moments until our screen is ready and showing all the elements that it has. So if we don't wait in between, it could be that Appium is already trying to find an element, like the Get Started button, but it is not visible yet. So in that case, it would not find the button, try to click on it, and then fail. Therefore, the most basic way to avoid this is to inject a very basic sleep for 1 second or 2 seconds. Now, once we finished all our steps, meaning clicking on all these different buttons, we can then go ahead and try to find the Wikipedia logo. So what we do here is we find it by accessibility ID, and then we just assert that it's displayed. If it's displayed, our test case succeeds. So let's have a look at how this test case would look like if we execute it. So if we run our code, we can see we have the Appium server on the right and an iPhone simulator on the left. So if we run our code, we can see the Appium server is receiving commands. It will install the app on the test device on the left, and then execute the actions that we defined before. Clicking on Next, clicking on Get Started, and then finding the Wikipedia logo and finishing the test. Yeah, so this is basically the most basic way you can write Appium code. So this would be a very basic example use case. Now, most of the time, probably, we would like to test a real application that has more than only one test case. So in that case, we would need to use a test framework. So in our case, we're using Java to write our test cases. So we could use TestNG as our test framework, and our stack would then use Java, Maven, and TestNG. Now, TestNG is a test framework, and it provides several benefits that are very helpful for us when we want to test our application. The first would be that we can have a test suite, which allows us to define which tests we want to run. For example, a class with several test cases or several classes with several test cases that we want to run. And it also allows us to define, for example, which devices we want to run these tests on. We will have a closer look at how this will look later on. It also allows us to have setup and teardown methods. These are basically methods that run either before each test method or once before each test class and after each test class, before a test group and after a test group. We could use them, for example, to set up our Appium driver before the test, use the driver for the test, and then tear it down afterwards. It also allows us to use listeners. We could, for example, use a listener that listens to the test state failed. And if the test state is failed, it may, for example, take a screenshot for us so that we can later on figure out more easily what went wrong. And it allows us to have parallel execution. So we could run the test on several devices with maybe different OS versions at the same time. And yeah, of course, it provides us with assertions like checking whether a statement is true, false, equal, yeah, etc. But let's have a closer look at how the code would look like. So if we set up a test framework in our project, it would probably look like this. As we're using Java, Maven, and TestNG, we have certain files here. Because of Maven, we have a POM, of course, where we define our dependencies like Appium, Selenium, and TestNG. We have a test suite due to TestNG, where we define the test cases that we want to run and maybe more details on how we want our driver to be set up. We will have a base class where we define our pre-test method, post-test method, etc. And we will have our actual test code in a test class. So those files that are highlighted purple here, we will have a closer look at. So this is how a test suite in TestNG would look like. You can see here it has a name. It has some definitions here on what would run parallel and how many threads it should have. It can define your class that is responsible to be the listener. And then the most interesting part, you have your actual test definition. So we see here we have one test defined, and we provide some parameters with it, which means we will use these parameters for the setup of our test driver. We can see later on how our test driver can read these parameters and then set up the driver with it. We can also specify the classes that we want to execute and the methods, the actual test methods that we want to execute in our test. So let's have a look at our base class. In our base class, we have some basic variable definitions, like the name of our application, on which URL the server is hosted. We set up the driver and utilities that we can use later on. Then from TestNG, we have these annotations, like the @before_class annotation. This one will make sure that this setup method will be run one time before each of our test classes. And we also have a @parameters annotation. This one allows us to inject the parameters that we had in our test suite before to be injected into our driver. So we can see here that we're then setting up the driver similar to how we did it before, with all the parameters that we're reading from the test suite. And yeah, we're setting up the capabilities. We already have the driver URL, the server URL, and then set up the driver with it. Now, additionally, we will also have an after method and an after class method. So in our after method here, for example, this one will be run after each of our test methods. We will check the result of our test. And then if it is failed, we take a screenshot here. Of course, you could do whatever you like in there, but oftentimes it's very useful to take a screenshot after a test failed to see what went wrong. And as we set up our driver before each test class, we will have this after class method, which will take care of the teardown, which basically means quitting the app, removing the app, and quitting the driver. Now, our test code would look something like this. We basically have a class that extends our base class so that our driver and utilities are available. And then each method that we want to run during the test, we just define with the @test annotation. Yeah, so this is some basic code, clicking on elements and asserting that certain things are visible. It's rather similar to what we did before. So we will not pay too much attention on that here for now. All we got to know is that for our test methods, we extend our base class and then use these @test annotations. Okay, so much about the test framework, how we would set it up. Now, oftentimes it's also useful to use a mock server, because currently our UI tests are end-to-end tests. And what this means is that the outcome is not only dependent on our own application that we're testing, but it's also dependent on the backend and the data stored in our database. So if there's some logic flaw on the backend, or if the data is not in the state that we need for our test might fail, even though our app is behaving correctly. So by using a mock server, we can avoid that, because a mock server allows us to simulate an API, and therefore it allows us to focus on testing only our app. Now, there would be a few steps involved in setting up a mock server. We will just go over them briefly, as we don't have a lot of time today. Basically, what you would need to do is get your request response pairs, which would mean that you would record your network requests, or if you have a Swagger file, you could use that. You could just modify it in the way you need it. So you get your request response pairs. You would then set up your mock server. For example, you could do that using Postman, or you could use your own solution. So you just use your request response pairs to set up a mock server, and then you would get a URL which you can use to access that mock server. In this case, we would also need to modify our application to change the base URL to our mock server, and maybe also have some additional modifications. In the case of Postman, for example, we would also need to include some additional headers to make sure that Postman matches our request exactly according to the parameters provided in the request. So a mock server can definitely be very useful in your automation testing, but sadly we don't have much more time to talk about it today. Also, regarding the CI/CD integration, we will just go over it briefly. Basically, what a CI/CD is, it's an abbreviation for continuous integration and continuous delivery or continuous deployment. In simple terms, it's a pipeline that helps you to automate tasks like merging, testing, and building your code. And it makes sure that your software is always releasable or even deployed automatically. So there are several tools available that you can host your CI/CD pipeline on. One very popular one is Jenkins. Yeah, so let's have a look at how we could set up a CI/CD pipeline with Appium. So you could imagine that you're working on your app, either on the iOS app or Android app in Xcode or Android Studio. You made some changes. You then push them to your remote repository, like, for example, a Bitbucket. Jenkins will then see that there have been changes and pull the code. It will automatically trigger the pipeline and run the unit tests. Maybe you run a Sonar Cube scan to scan the code, and then build the application. After the application is built, we could start our Appium process, which would basically mean we would start the Appium server, and we would then run our Appium tests, maybe using the same stack as before, using Maven, TestNG, and Java. And after those tests are run, it would then generate a report and potentially automatically deploy to the App Store or the Play Store, or just tell you everything went fine, and here is your runnable app file, like IPA or APK. We need to make sure here that the Appium part is run after we have built our application, because we can only run our tests with an APP file or an APK file, and we can not execute it before the app is built, like, for example, for a unit test. All right, sadly, we cannot spend much more time on CI/CD integration today. So let's summarize the benefits and limitations of what we have learned about Appium so far. So first of all, Appium provides us with quality improvements. Once you have your tests, it will be very easy for you to run them, and you will trigger them more frequently than you would have otherwise. Maybe they are triggered automatically by your pipeline, or maybe you trigger them whenever you like, but probably more often than if you would have to run it manually. Also, yeah, you don't need to ruin your QA team's work-life balance if you want to run the tests overnight or on a weekend. So yeah, Appium provides you with quality improvements and gives you more confidence in your application. Running the tests will be comparatively time-saving, as the tests can be executed anytime and they can be executed in parallel on different devices, which means you can have faster release cycles. It takes less time for you to be sure that your app works fine and you can release it. Another big benefit of Appium is that it is open source, which means it is free to use for you. And if you have know-how, you can even contribute yourself to keep Appium alive and move it in the direction you want. And yeah, also you can pick whichever programming language you want, as long as it's supported by Appium. So you can pick the one that you feel most familiar with. Of course, Appium also has some limitations. The first one would be that you usually need a programmer to write the test code. So you would need someone who has at least some experience on writing code. It's not always super complicated, but the person needs to be familiar with writing code and to have some general understanding of what's going on. Your test code may also have issues. This could, for example, be to using a suboptimal locator strategy like XPath, which is brittle, that can break over time if you, for example, do modifications to your app. Or it could be due to an OS update that changes something. For example, if you would want to automate the system settings of your device, then maybe with a higher OS version, the way to automate that would change. And then your previous commands wouldn't work anymore, and you will need to modify your code to make sure your test cases work fine. Then there are also certain hardware limitations, meaning there are some interactions that we can't or that are just very difficult to test. For example, interacting with the camera or interacting with an external Bluetooth device. These kind of scenarios are not that straightforward to automate. Some apps are also not really suitable for automation testing. For example, a 3D game would probably be possible, but very difficult to automate. So yeah, using Appium for that might not be the best choice. And also, your Appium tests will check exactly what you defined in the code. This is usually a good thing because that means they're exactly following the test case. However, it misses the human component, like the human that maybe would realize that there's a typo somewhere that is not specified in your test case, or that the UI has a glitch, or that something is not consistent, the user experience is not perfect. Yeah, something like that. So Appium will always just check exactly to the code. Okay, let's have a look at our demos. We will have 4 demo scenarios here that I want to show, basically showing on what you can automate with Appium. We can see here we have the IO simulator on the left, Appium server on the right, and a command line to trigger our test cases. So we're starting up the server, triggering our test cases, and then Appium will start installing the WebDriver agent and our app on the device. Once this is done, it then starts automating the app. We can see it already skipped the intro. It searches for an article and then adds it to a list. We then go back and check our list to see whether our article has been added. So yeah, this is a rather basic example test case that shows us basic interactions like clicking on items. Excuse me, like clicking on an item, sending keys to a text field. Yeah, so very basic interactions, similar to what we did in our first Appium script tutorial. Now, this test case is a little bit more advanced. It looks pretty much the same, but the main difference here is that we're interacting with a web component, meaning the articles in Wikipedia, they're implemented as a web view. So if we want to click on a link in that article, like we do here, we basically have to switch the context from native to a web context, then use Selenium code to interact with it. Once all our Selenium code is executed and we have gone to this page, we then switch back to the native context and yeah, finish our test case. So in our code here, we can see we have first our native interactions, like searching for an article and opening it. We then see which contexts are available, and once the web context is available, we switch to it. We then use Selenium code, which looks pretty similar to Appium code, with the main difference being here that it's using a different locator strategy. We use it to click between different articles, and once that is done, we're then going back to the native context and go back to the main screen. yeah, this is just as an example to show you that you can also automate web views with Appium. Now, in this demo, we will show you how to perform a gesture. You can see the same setup again, Appium server and device, and we trigger the test case using the command line. What this test case will do, it will open an article and open the photograph of that article, and then use a gesture to zoom in. So if we look at our test code here, the interesting part is the gesture. We can see we calculate all the points that we need to perform the gesture, meaning we first get the screen dimensions. We then calculate where the starting point for finger 1 is, where the end point is, the same for finger 2, and then create a touch action consisting of a press, a wait, a move to, and later on a release, and the same for the second finger. And then we combine them in a multi-touch action and finally execute it. Yeah, if you have more interest in gestures, I can also tell you more about it later on during the Q&A session. And now we have one last demo. So here, the setup is a little bit different. We also have Appium server and the command line to trigger our tests, but we can see here that we are having 4 simulators at the same time. And we can see the tests are all executed at the same time. So one of the big benefits of TestNG is that you can perform tests at the same time on different devices, giving you faster feedback. Yeah, this would continue for a while, but we are a bit short on time, so I'm just going to skip that here. All right. Now let's have a look at the market trends. So we learned a lot about automation testing now. But yeah, especially recently due to the COVID pandemic, mobile application consumption has been rising a lot because people need to use their devices more. This leads to a higher competition and pressure for app providers to deliver better quality and functionalities more frequently. So it leads to more frequent release cycles. And this, for the app providers, this can become very costly because, of course, they want to make sure that the quality is all right. So they have to test a lot. So therefore, automation testing is a growing trend. Currently, the biggest market is the US, but it's growing the fastest in the Asia Pacific region. Yeah, so the goal in general is to reduce time and effort and therefore reduce the cost. And one of the goals would be to reduce the time that is wasted on reoccurring test cases, yeah, as well as the skills that are required to execute them. Now to our last topic for today, TPI's own automation testing solution. So as we heard before, automation testing is becoming more and more important in the future. Automation tests allow you to test your app more frequently and faster than a manual test, and it's a great way to improve the quality of your application. So we at TPI developed our own automation testing solution, which is based on Appium. Basically, our solution helps us to organize the test code by test cases, and then automatically generates the Appium test code when the tester executes the test on the device. After all the test cases are executed, our solution then automatically can generate a ready-to-run Appium project for you. This helps us to speed up the test generation process, which can be often quite time-consuming in Appium. So we can save up to 60% of the time that it would take to write the test manually. And furthermore, we can provide a higher script quality as we reduce the risk of manually introduced errors. Our solution supports BDD, behavior-driven development, which means that you can use, for example, built-in feature files if you use them in your development process. And we can also support you to integrate the automation test project into your automation testing, into your pipeline, into your development pipeline, so that you can continuously run your tests. At the moment, we are supporting native apps on iOS and Android, but we are working on supporting other technologies like hybrid apps later on. All right, let's see a quick demo on that. Basically, what you can see here on the left side, you can see a tester using TPI's automation testing solution. And on the right side, you can see the manual process of writing Appium test code. On the right side, we can see the development basically consists of switching back and forth between the Appium inspector and the IDE to find elements, then write the code to interact with that element, find the next element, interact with it. On the left-hand side, we can see TPI's automation testing solution. We can see the tester can just use the app as they normally would during the test case and record the test. Once the test is recorded, the script is automatically generated. And once that is done for all test cases, all steps in your project, you can then generate a ready-to-run Appium project. Yeah, this is an example that would keep going for a while, but we are a bit short on time. So I'm going to stop it here for now and going to recap on it. So on the left-hand side, we saw TPI's automation testing solution, which can speed up the process because it is a lot easier and faster for the tester to generate test code by just using the app as they would normally during a test case. Whereas on the right-hand side, we could see a person writing the test code manually, and we could see that it's rather tedious, switching back and forth between the IDE and Appium Inspector. Yeah. If you have more questions on it, feel free to contact our sales, and they'll be happy to provide more information. For today, we're a bit short on time, so I have to finish up now with a short recap of what we learned today. Basically, we learned what testing is and what methods and tools are available to test software. We saw how UI testing is performed manually, and we learned a lot about Appium. Appium can help us to automate our UI testing. We know now how it works under the hood, out of which components it consists and how they communicate with each other. We have learned how to write a basic Appium script, which consists of setting up a driver, finding and interacting with elements. We then learned how we would set that up for a larger project, for like a real project, so that we can not only have one test case, but several. We had a quick look at how we could use a mock server or a CI/CD pipeline to improve our automation testing. And we finally elaborated on the benefits and limitations that come with Appium. Yeah, last but not least, of course, we also learned about TPI's own automation testing solution and which benefits it can provide to you. Thank you, everyone, for listening. That's it from my side. We will now continue with the Q&A session, and I will hand over to Peggy.
Thank you very much, Karl, for this amazing presentation. I hope you all enjoyed this presentation and have gained some insights into how mobile automation testing works with Appium. Now we're going to have a Q&A session to answer the questions that were sent to us during the presentation. So please stay tuned till the end of the webinar. I'll read out the questions on behalf of our attendees, and our speaker, Karl, will answer them. We've got quite a lot of questions here. Okay, so the first question is, can we also automate stress tests such as simultaneous users accessing a web app in a specific time frame. Karl, please.
So what we can do is we can, what I understood was using apps simultaneously. So you can have a multi-app scenario where two apps are communicating with one another. You can have that kind of flow. Regarding about stress tests in particular, I have to admit this is not my experience, so I cannot give you any insight on that. But if you're interested, we can have a further look into it and reply to you later on.
Okay, let's move on to the next one. Hi, Karl. Is Appium best to use for integration testing? And can it be used for monkey testing? Monkey testing.
Monkey testing. So monkey testing usually means that you're clicking around wildly in the app and try to break it. You can definitely automate clicking around wildly in the application. However, for a proper monkey test, I would assume that it's a bit difficult because Appium doesn't know automatically when a behavior would be incorrect. So what we always need in the end of our test case is some kind of assertion to check whether the outcome was correct or incorrect. So I would believe Appium might not be that well suited for a monkey test.
Okay, thank you, Karl. So let's move on to the next question. What is the general approach to perform a gesture in Appium?
Yeah, good question. So we saw one gesture in the demo before. So in general, if we want to execute a gesture manually, we will need to look at the coordinates of the screen or the element that we want to perform the gesture on. So we would either get the coordinates of the screen or the coordinates and position and size of the element that we would perform the gesture on. For example, you could imagine that you have a list which only spans over half of the screen. You would then get the coordinates and dimensions of that list and then use that to calculate where you would need to move your finger to automate that gesture. So for example, if you would want to scroll the list, you would probably move your finger from the bottom up. So you would use one of the lower parts within the list and then move it to one of the upper parts. Yeah, one thing we need to take care of every time we perform a gesture is that it can have an interference with the system gestures. So for example, if you perform a swipe gesture and you start from the bottom of the screen, you may accidentally quit your application by swiping up as you would usually do to quit an app on iOS. Or if you would start swiping from the top of the screen, you might accidentally open the notification center instead of what you were originally planning to do.
Hey, thank you, Karl. So the next question is, in one of the demo videos, you mentioned that you switched to a web view context. Can you explain more on that?
Yeah, right. So in the second demo video, we showed an example where the app was switching back and forth between the native context and the web context. Basically, many apps have web views, which can display web content. The downside of these web views is that we cannot access their elements, the elements that are displayed inside of the web view, with native Appium automation. So in that case, if you have a web view like I think it's called Chrome view on Android or WK web view on iOS, if you have that in your application and you want to automate it, you would first need to see whether the context is available. Once it's available, you would switch to the web context and then start automating it. For that web context, you would usually use Selenium code. However, when you use Selenium code, you maybe have some already that you recorded on a real website. You would always need to be careful that the website may be displayed differently in a mobile view than it would be in your desktop where you did the recording. So this is something you need to take care of. And also, if you would want to perform gestures, you cannot perform them on a web view. You would need to switch back to the native view to perform the gesture and then switch to the web view to keep automating it. So yeah, you can automate web views, but you need to switch back and forth depending on what you want to automate.
Okay, thank you, Karl. So let's move on to the next. Hi. In the sample code, we can use idling, but are there functions such as idling to wait for callbacks?
Oh yeah, very good that you mentioned that. So yeah, as you saw correctly, in our first test case, we used the thread.sleep statement to wait between different clicks, and we used a hard-coded 1 second or 2 seconds to do that. This is not best practice, but it's the most basic example. There are methods that allow you to check for the presence of an element or visibility or whether it's activated. So I would actually recommend you to do that, to check whether a certain element is visible before you interact with it. This has the huge benefit that, for example, if your machine is very fast and you have these wait statements, it will all go a lot faster. Your tests will perform faster because there's no time wasted waiting, even though the app is ready already. And also, if you maybe run it on a slower machine or your machine is very busy with something while you run the tests, the test will not fail because maybe an element is not yet visible before the time times out. So yeah, very good that you brought that up. I would not suggest you to wait by actual seconds whenever you can avoid it, but instead wait for the visibility of an element or wait for an element to be clickable.
Thank you, Karl. Okay, the next question is it considered simple or difficult to automate a two-factor authentication sign-in process, for example, SMS and biometrics?
Yeah, so for two-factor authentication, you would need your app to log in, but of course you would also need to read a text message or use some third-party two-factor authentication application. I personally would consider it a bit more difficult because you would need to add a lot of additional logic navigating to another app and getting that two-factor key. For example, as you mentioned, there could be an SMS. So you would, on your testing device, you would need to be able to receive text messages. You would then need to wait for the message to arrive, check your notification center, go into the Messages app, find the right message, and read that code. So I think it's possible, but it would be quite complicated to do it in the exact same way a user would.
Thank you, Karl. So our next question is, can I use Appium to automate Safari or Chrome?
Oh, good question. So your question here is not to automate the app under test, like the app that you developed yourself, but probably a website in Safari or Chrome, I assume. So yes, you can do that. Basically, what you would do for that would be that you, instead of the app capability that we saw before, you would provide a browser capability with either Safari for iOS or Chrome on Android, and then start your Appium driver. That would automatically start the Appium driver within into your Safari app or into your Chrome app on Android. And then you can use Selenium code to automate that website. As mentioned before here, it would be important that you make sure your Selenium code works fine on the mobile side. So for example, if you recorded the Selenium code using the Selenium IDE on Google Chrome or another browser, you reused that to automate the browser. It could be that the mobile UI is different and therefore your code may have some flaws. So you would need to check whether your Selenium code works fine. But yes, it's definitely possible to automate Safari on iOS or Chrome on Android.
Thank you, Karl. Now let's have the next question. Can Appium be used to automate hybrid apps like Apache Cordova or Ionic apps?
Right. Yeah, you can also use Appium to automate hybrid apps. One thing you need to keep in mind here is that hybrid apps are usually implemented using a web view. So similar as we mentioned before, to automate a web view, you would need to find the web context here and then switch to the web context to automate it. So most of the hybrid apps are a web view and have most of their content displayed in a web view. However, they can also have native components within the hybrid app. So for these test cases, you need to make sure that you execute them within the web context and then switch to the native context whenever you have such a native component in your hybrid app. There's also one convenience feature from Appium that lets you switch directly to the web view if you know that your app maybe only has a web view. So you could set up your driver with that, like auto web view, I guess is the name of that capability, and then start automating the web view right away without needing to change the context manually.
One more question before we wrap up the session. So the question is, can I change the system settings of the device under test? For example, I would like to test how my app behaves when location services are turned off.
Sure. Yeah, you can do that. For the iOS simulator, this is very convenient as there's a plugin that exists that allows you to inject the system settings as a JSON when you're setting up the driver. So there you could say right away, okay, location services turned on or turned off, or notifications turned on or turned off. You could specify all of that there. However, that one sadly only works for the iOS simulator. If you try to automate your app on Android or on a real iOS device, you would need a different solution. One thing you can always do is, as you can automate not only your app, but the operating system, you can navigate to the settings app of your application, of your device, and then change to the settings that you like turning off location services or turning them on however you need it. So this would be a little bit more complicated, but it's still possible.
Hey, that's all for today's Q&A session. Thank you, Karl. Hey, our speaker comes from Global Professional Service Department, and this is an international team with working experience across multiple industries around the globe. They have expertise throughout the technology stack, such as Android, iOS, backend, and web development. And they have strong expertise in mobile automation testing and microservices. If you want to learn more about our automation testing solution, feel free to contact us via email or the questionnaire, and we will contact you shortly. Okay, we'll prepare today's materials for you. So before you leave, please click the questionnaire link we've just sent to the chat box or scan this QR code to fill out a brief questionnaire and tell us how do you think about the workshop. It will only take a few minutes of your time to complete. Your feedback would be greatly appreciated. And we will send you the slides and a link to today's video recording for anyone who submits the questionnaire. So be sure to provide your email so you won't miss out the slides and the video link. For the questions not answered, or if you have any questions, please leave your contact information in the questionnaire and we'll get back to you as soon as possible. And would you like to learn about trending tech topics and our future event? We've hosted a number of workshops on diverse topics such as Dapper, Blazor, Big Data, and more. We send monthly newsletters that cover our event and articles on tech trend. So please subscribe to our monthly newsletter and our blog, and follow us on LinkedIn so you can stay updated for our latest news and future events. Hey, don't forget to submit your questionnaire before you leave. Once again, thank you everyone for attending today's webinar. We hope to see you again next time. Thank you. Bye.